There are some stories in the universe that don't just surprise us, they challenge everything we think we know. Stars are born, they live, and eventually, they die. It's a rule we've trusted for over a century, but in 2014, scientists witnessed something terrifying. A star exploded, and then it just kept going. It didn't fade, it didn't die, it burned for over 1,000 days. This is the true story of the star that refused to die. And it might be the weirdest supernova ever seen. To understand why this star is so strange, we have to understand how stars normally die. Massive stars are like nuclear engines. They fuse hydrogen into helium, then helium into heavier elements, all the way up to iron. But when they run out of fuel, their core collapses under its own weight, triggering a supernova, a brilliant, violent cosmic explosion. The outer layers are blasted into space. The core either becomes a neutron star or collapses into a black hole. After that, silence. The explosion fades after a few weeks. The show is over, or so we thought. In September 2014, astronomers at Caltech's Palomar Observatory noticed a familiar light. It was a Type II supernova, and it looked pretty normal. They named it IPTF-14HLS, also some calls it the zombie star. At first, it behaved as expected. It brightened, peaked, and was expected to fade. But then, something strange happened. After 100 days, it was still glowing. 200 days, still bright. 600 days, it was brighter than ever. It wasn't just staying alive, it was pulsing. Its brightness rose and fell in 5 major waves. Supernovae don't do that. And just when scientists thought it couldn't get any weirder, someone checked an old telescope record from 1954. The same location showed another supernova. It looked like the same star had exploded before. So how is this even possible? How can a star explode twice? Well, here are the leading theories. The first one being pulsational pair instability. This happens in supermassive stars, over 100 times the mass of the Sun. Inside, gamma rays convert into electron-positron pairs. This destabilizes the core, causing partial collapses and mini-explosions. The star sheds layers but doesn't fully die yet. Could this explain IPTF-14HLs? Maybe, but this theory predicts a few pulses, not 1,000 days of chaos. The second one says it's a magnetar inside the explosion. A magnetar is a neutron star with an insanely powerful magnetic field. It can pump energy into the supernova debris for an extended time. This could keep the star glowing longer. But again, not for this long, and not in repeated pulses. The third one, binary system gone wild. What if it's not just one star? Some think this was a binary system, where one star exploded and its companions somehow re-fed material into the chaos, causing a delayed reignition. Interesting? Yes, but the data doesn't quite line up. And finally, when it all shatters, the fourth theory tells it is something we don't understand. When all else fails, scientists have to admit something uncomfortable. What if our model of how stars die is wrong? What if we've only scratched the surface of how stellar collapse really works? This isn't just one weird star. It's a warning, a reminder that the universe isn't finished teaching us. Stars like IPTF-14HLS could reveal entire layers of cosmic behavior we've never even imagined. If stars can defy death, what else might we be wrong about? How many other impossible objects are out there, just waiting to be found? One mystery solved might open the door to 10 more, a star that exploded and came back, and might have done it again. That's not science fiction, that's a documented event. Subscribe to Beyond Light Years for more cosmic horror hiding in plain sight. And let us know in the comments, what if stars can cheat death?